This conference will now be recorded.
Hi, Math 211 students. I recorded this video and the audio was not working, so instead of just reworking the problem completely, I'm just going to walk you through my steps. This is in section 4.1. I did a little bit of example 1 that we didn't get to in notes that day, and I also did example 2 again. So this is what is the area under the graph f of x equals x cubed plus 1 in 0 to 1. In class, we figured out how to represent that as a limit of a Riemann sum, and then we did the midpoint 2, which means that we used 2 intervals or 2 rectangles for our area, and we evaluated the function at the midpoint for both of those intervals. So for the next part, we wanted to do right endpoints and left endpoints. I did the left endpoints first, so let's follow through with that. So L4 means your subintervals, there's 4 rectangles, and we're going to use the left endpoint of each. So to figure out that, you have to look at your interval that we're on, which is 0 to 1, and we need to find our delta x, which is always b minus a divided by the number of rectangles. So that comes out to 1/4. So we need to split 0 to 1 into 4 rectangles where we use a fourth as the width of each interval. So that's 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, 3/4 to 1. Then since we're doing left endpoints, notice those are my black arrows. I picked all of those values and I plugged them into my function. X cubed plus 1 was the function. And I found the evaluation of each of those. So that's 165 over 64 because we're cubing, 9 over 8 because we're cubing again, and 91 over 64. So then L4 is equal to the sum as I goes from 1 to 4 of f of x sub I, which means any of our heights of any of our rectangles times the width of each rectangle. So that's 1/4 because delta x is a constant for each rectangle. It's the same width for each rectangle. So we can pull that to the front. And then these are just the heights of the different rectangles. So then when we get a common denominator, I went ahead and added all those together, and I got 292 over 64 times 1/4, which reduces to 73 over 64. And I'm going to go ahead and rounded that off to 1.14 just so we get an idea of what this actually represents. And remember, this is not saying that this is the exact area of that region. In fact, it's not. It's an approximation. And since the function is increasing from left to right, and we're using left endpoint, this is going to be an underestimate. It's going to be too low. And then this is R4. Again, the only difference here is we're using the right endpoint. So we already know the function values for 1/4, 1/2, and 3/4 because they also showed up as left endpoints. The new one is going to be 1. So I evaluated 1 as well and got 2. So my right endpoints using 4 rectangles would be the sum from I equals 1 to 4 of our f of x sub I is delta x, which is again still 1/4 times all of the rectangle right endpoints evaluations in the functions. So I add all those together and get 356 over 64, and then multiply and reduce essentially, and I get 89 over 64, which is roughly about 1.39. And since this function is increasing from left to right, that's an overestimate on this interval. So notice that the area of the actual piece under the curve between x cubed plus 1 on 0 to 1 and the x-axis is somewhere between 1.14 and 1.39. Okay, then example 2 was just one, like kind of part A of example 1. I just wanted to make sure we had this one written down. So you're finding the expression of the area under F as a limit, but do not evaluate it. So we're doing the limit of the Riemann sums. So this is, again, finding your delta x is crucial. So delta x is 7 minus 4 over the number of rectangles, which is unknown at this point. So that's just 3 over n. X sub I means what are those endpoints in your rectangles. Now I use right endpoints because it's easier, because if you use right endpoints, you start with your very first interval number, so that's 4, and then you just add the length of each rectangle, or the width we call that sometimes, as many times as you want, which is what the I represents. So this would be 4 plus 3 over ni. Then to get this into Riemann sum, you need the f of x sub I. So we plug that 4 plus 3 over ni into our function for both places where there's an x. That's what gave me this. And then the area is equal to the limit as n approaches infinity of r of n, which means as our rectangles approach infinity, the number of rectangles that we have using right endpoints is the limit as n approaches infinity of the summation I equals 1 to n of our function notation at x sub I times our delta x. All right, and that's it. I just wanted to make sure, since the audio didn't work the first time, that I got you guys this video.